It is June 2024 when I'm recording this video. Lately, I think it has been more than I've ever seen where there's question around should a Scrum Master be technical or not. Scrum has been around since '93, so it's been around for a long time, and there's been multiple changes along the way as far as the Scrum Guide is concerned. Now, this is one of the videos that I kind of put off for a little bit. Wasn't sure if I was going to even release this or even make it. I put together some stuff, and then, in the course of doing those things, a lot of things has happened in the marketplace. We've seen a lot of companies transition away from Scrum. I would say maybe towards not having Scrum Masters more than anything else, and then allowing the teams to run Scrum on their own. And this begs the question, is the value of Scrum Masters? Are there any value of Scrum Masters? And along the way, I've seen folks saying that, one of the reasons why Scrum Masters is not valid is because they don't have technical experience or technical background or technical understanding. So therefore, right, because they don't have it, so therefore they should have it. So for those of you wondering then, should a Scrum Master have a technical background? I think my answer is gonna be no. But should they have some technical knowledge? I would say yes. And what is that? And even if you don't have it today, I think it's something that you should pick up as a Scrum Master. You should know the domain that you're in. Scrum is an iterative process, right, towards building software. Agile is about software development. Check out the Agile Manifesto. It states that it's for software development. So as a Scrum Master, you should know software development. Now, what does that look like? In this video, I'm going to share with you my thoughts on what that is. I'm going to give you the basic fundamentals. It's not everything, but I think it's enough as a starting point for you to either take it further or for you to understand a little bit about software development. So I'm going to start with the basic, I consider as basic software or application development, and then I'm going to talk about coding itself. So let's start with definitions. What is a software? A collection of group of instructions that perform certain tasks for a user. Now, often referred to as a program or executable. So if you're living in that world, you should hear these words, right? It's a program or it's executable, it's software applications. Now, for me, there are three different groupings of software applications. Number one, they are either time schedule, right? So based on specific time, the application activates or it runs. So think about batch files and things like that. The other one is very basic that we all know, which is called the user input. When you do something, something happens, right? When I go type on the browser, when I log into the application, when I do my mouse clicks, then something happens. Now, the last one is what I considered audio based, right? It's gonna be more like our, those listening devices that we have, the smart devices. I would say the Google, right? Things like that. The Google Nest, I think that's what it's called, where it listens on your keywords and then it does something. Now, this is still input based, but it's based on more, I think the architecture is where you listen to everything, right? It's constantly on, constantly listening to what's been said, but then it'll pick up the keywords. And based on the keywords, then it does something. So for me, those are three categories. If you are watching this and you find that there's more to this, please share in the comments below. So examples of applications are basically, the simple ones is your calculator. Now, a calculator is very simple. It's on a specific device, right? It's just a simple basic calculator, add, minus, things like that. You do something to it, and then you get results from it. Now, going to a little bit more complex, I would say it's like the context application that you have on your phone or on a computer, right? I remember doing this back in the day as part of my assignment, creating a context application in COBOL back in a long time ago, right? So all it basically requires somehow, you do some input to it and then you save it. You have to store it. So it requires some sort of persistent storage. So of course, this requires more functionality, right? Now, if you think about those things, think about the application that you use today. Which one is the simple one? Which one requires a little bit more, which require storage? As the years goes by, as we think about how we use the application, as they become more and more used, more and more widely adopted, it got to a point where the architecture of the software itself changes. Think about your calculator, right? The calculator as it stands in an actual calculator device, the hard device, how often do you update the software on it? Not a lot. How do you, you know, sell more of the application or call the calculator? You sell devices, right? And then the software gets installed onto the device, the hard device itself, and it gets sold as a unit. Think about that adoption of it. And then think about, the context application or the application that sits on your phone today. How often do you update those? Think about the things that it requires to update. So the more people that use it, requires downloads and things like that, the more things change in terms of how we architect the application. So version changes, updates, mass adoptions are used, reusability and efficiency becomes the key factor in how we design and develop software. As part of the effort of, becoming more efficient with our time and efficient with the use of the application, right? We got into this world of what we consider as layering of the code, layering of the application. One single application nowadays is just not one unit, but it consists of multiple different layers. Now, the basic fundamentals is you can think of it as having 3 layers. Of course, some of you might, reject the idea and give me more, but I think there's basically 3 fundamental layers. So layer number 1 is usually what we see, what we deal with as a user. That's called the user interface. It's tend to be called the front end layer or the UI layer. The second one is kind of where things happen, right? More complex things happen as we got input, and what do we do with the input, right? There's some transformation happen, some calculation happen, some mapping happens in there, some codings happen in there, things like that. That's the processing layer, right? To me, that's like the middle layer, and that's where the business layer stands in, the business logic. Now, finally, there is the third layer, which is called this storage layer or the backend or data layer. This is where we store data. So think about the context applications that I spoke about early on. That's where it resides. So data has to be stored somewhere so that we can retrieve the data and reuse it. So that's the 3 fundamentals layers that I see. Of course, there could be what we consider as the nth layer architecture, which some of you may be aware of. If you think about all this layering and things like that, then it comes into, well, the pieces of code that we share, right? We don't want to rewrite a bunch of old things. Example is the profile, right? User profile is a user profile. We should not be rewriting it all the time. It can be written once and shared in multiple different applications or different layers, for example, right? The login, similar things. Security, right? How we handle security. As a company, you might want to be writing it once and being shared across your different modules. The way we calculate things, right? Calculation, standard way of doing it. It should not be any different. This saves time. Again, this reduces the potential differences in how we do things. Standardize things is one of the things. So this is the modular way of coding. Now, we're living in that world today where things are kind of in a small unit, right? They get shared around multiple times or shared around or called upon by multiple different applications and modules. If you think about all these complexes and things like that, they are all very complicated because all the way the front end, the back end, the middle all have to interact with each other. Now, think about also the modularity of the code. The login might sit in the different places, right? They're calling to talk to the profile layer. They're calling to talk to the security. All those becomes very complicated, and they're all interconnected. And not just interconnected, but they're also distributed throughout different places. They're on different servers now. There's cloud. There's all these different things that's happened. In order for all this to work together, there requires a contract and agreement between these different pieces of, you can call them code, modules, or services. They gotta have all that stuff, which makes maintenance and updates kind of, more complicated than it has to be. So think about all these things in there. So, whenever a version change happens, what changes needs to happen? Does it happen in the back end? Does it happen in the front end, right? Does the back end changes how we handle the front end? All those has to have what we call a versioning and testing and making sure everything still works the same. So that's the application or software fundamentals. You should know this, right? That's the core basic understanding of what a software is. And we're going to move on to coding. As part of a Scrum Master that works with software development teams, you should know some basic things about coding. This is what your team does, right? So you should know what it is. Now, the reason why you should know this is because you're in the role to help ensure that the team is delivering value, right? One of the ways to deliver value is getting feedback. So by understanding the process and the things that is needed to make software allows you to be better equipped in helping the team. Now, you do not need to have in-depth knowledge. You don't need to be able to write the code, but you need to be understand how the pieces come together, how people are using the different pieces. And it allows you to also stay on top of things. Like for me, for example, at one point, I was still going to conferences, like technical conferences for the matter, to understand what's happening, what are the new tools that's coming out, and staying, afloat, staying in front of knowing those technology, not necessarily using them, but kind of giving an understanding of what they do, as potentially maybe something that you bring up to your team. Hey, I heard about this software or this thing, and does it help you? And let the team figure it out, because they are the expert in this. So as a Scrum Master, it is not my place to tell the team what tools to use, what type of structure to use, what type of architecture should the team use. Not my place, right? As a Scrum Master, that is not my role. So things to consider when we talk about coding is, what are we building? What is it that you're going to go build? Because what you're going to go build determines what other pieces that you need to go build it. Similar to making a cake. If you're going to make a chocolate cake, the ingredients going to be different than making a vanilla cake, for example, or wedding cake. So some differences in there, but it's still fundamentally making cakes. So fundamentally, you should know how software is being built. So coding is what it is. Now, once you know what you're going to build, the next question is what coding languages to use. There's a bunch of those things, part of the coding language. Once you figure out what there is, then you didn't know what kind of code editor or in IDE that you need to use, right? Whether you need to use a compiler or interpreter, and then you still have to think about how is the code being tested. Also, your team might be using what we consider as framework. Framework are pieces of things that enable the team to write things faster. Frameworks are things that makes it easier. So back in the day, we don't have a lot of frameworks. We have to write everything on ourselves. But nowadays, a bunch of frameworks that's available today that enable us to better deliver the value, right? Not focusing on how, but focusing on using some frameworks to help us deliver the result faster. Of course, with all these things in place, then you got to consider, where are we going to store the code? We write it, where are we going to put it, so that we can, reuse the code, right? What storage or database you're going to use, when you talk about persistent storage, where we can store the data, and of course, how do you deploy the code? What tools are available to you to deploy the code? Here are some of the coding languages that's out there today. This doesn't mean to be everything. Of course, if there's something that I haven't mentioned and you're using it, feel free to share in the comments below. Some examples I'm going to call out. Python is very, very popular. C# is something that I'm familiar with. SQL, HTML, JavaScript is something that I've used in my past career. So think about things that may be new. Ruby, for example, has been around for a long time. PHP, for example. Once you know your coding languages, they all have their own different way of writing, what I consider as, how we're going to write it. What are we tools are we going to use to write it? And that will be your code editors. Simple code editors such as Notepad++, right? It's still coding. You're still writing something somewhere, right? It's kind of like putting pen, writing, using a pen on a piece of paper. You still have to write that, right? You still have to write the code. So where do you write it and what tool do you use? There is something called the code editors. Those are simple stuff. Atom, Sublime Text, Notepad++, Ultra Edit. Those are the more simple ones. Now, there's also things what we call the IDEs, the Integrated Development Environments, right? So those are the things that, Visual Studio Code is one of those. PyCharm, Eclipse, depending on which language you pick, it has its own, preferred IDEs. Now, again, if you have some that I haven't mentioned, feel free to mention it here in the comment below. Where do we store the code? Well, this is what we call the code repository. You write it, you gotta store it somewhere, right? Things like Bitbucket, Subversion, GitHub, Cloud Repo. Popular things is between GitHub and Bitbucket. I might be wrong in here, but those are the tools that I think, in my years of working that I've seen the most is right now. I think GitHub is one of the big ones. Again, if you disagree with me, let me know. Maybe somebody else has something better that's out there. Once you write the code, you have to test the code, right? So what kind of tools do we have that's available for us today? Here are a couple of those things that I have on there. This is not everything that's out there, but this is some that I was able to find. Some that I'm kind of familiar with, but I'm not a tester myself. Of course, I don't have in-depth knowledge. Some of you may have. Feel free to chime in and share some of the tools that you guys use for testing. Frameworks. This is something that's really popular. I remember back in the days, I used to work with a company called Telerik. They had Telerik controls and things like that. Those are frameworks that allow me to better write UI, right? Kendo UI is one of those things. I know things that I've come across. AngularJS has been quite popular. Spring, Django, Vue, React, and of course you got Ruby on Rails as well. Again, not everything that's out there, but some of those that you may come across. Let's talk about deployment. Once you have your write your code, you test your code, now we got to deploy it somewhere. There are tools that help us do the deployment. So unlike back in the days when I was working, we basically create executable exe files, and then we copy them and put it onto a diskette and mail the diskette out. Those were the old days. Nowadays we actually move files onto a server somewhere and then it gets downloaded. Think about your phones you have. It has to connect somewhere to download the new versions, right? So here are some of the tools that you may be having, or you may be working with, or your teams may be working with. The ones that I've come across, like TeamCity, Jenkins, GitLab, Octopus Deploy is quite popular as well. And the interesting thing is, CodeFresh, I can't even pronounce the word CodeFresh, is now or has been acquired by Octopus Deploy in April of 2024. I think previously it was by somebody else. So those are some of the tools that you should be aware of. All right, databases. Here are the list of databases. The ones that is closest to me the most is SQL Server. That's kind of where I grew up in. I know a little bit of Oracle, of course, for sure. The rest is very, very new. MySQL has been around for a while. MongoDB, SQLite, IBM DB2, fairly old, I would say. All right, so all those tools aside, if you are writing code for yourself, if you are a one-man show, it is very simple to do, right? You write your code, you have the tools that you use to write your code, then you test your code, then you deploy your code. Then of course, once you deploy it, then you gotta store it, right? So that then you can, put in a new version, update and things like that. So fairly simple. Now, if you're working in teams, this is where Scrum Master is. Most of the time you are working with teams or a group of individuals that are working together to deliver software. So now this comes with some complication, right? You got to think about how you share your code. How are testers going to test your code? Where does your code go to so the tester can test it? If you have multiple working on what we consider the same branch of coding, where are we working on the same branch or working on different branching? Then you got to think about what we consider as remote and local repository, right? Locally, I can download and write my code, and then I'm going to upload it somewhere so other people can take a look at my code or share my code, for example. So all this in terms of how we collaborate as a team becomes more complicated. And that gets into what we consider as the coding management. How do you manage all these different versions of code? There are terminologies that's out there in terms of this. These are some terminologies that you should be familiar with as a Scrum Master. If you don't know what they are, you can go Google them. You need to know what a branch is. You need to know what a fork means. What does it mean to fork a piece of code? What does it mean to push? What does it mean to merge, to commit, to pull, to create a pull request? You need to understand this. Why? Because oftentimes this is the steps that your developer has to go through. And along this path, they may encounter certain things. For example, when we do a pull request, nobody's responding to it, for example. Well, why not? Right? So you need to consider all this stuff. All this is to say that it is complicated. You should have some understanding of it. If you do not, you need to find the time to learn this. With all these different things in there, when you're writing code, the team has to deal with what we call different environments, right? As a software engineer, they dealt with what's called a development environment where they write their code in, and then they gotta test it. right? This is where your testing environment comes into play. Where do I move my code to so others can do testing? Where do I move my code to so that other people also merge the code together and then we can test it? And of course, once you write the code and test the code, where do we demo from, right? If you're doing your sprint review, what is a place where I can put my code to so others can take a look at it? And then you have what we call the staging environment, and then finally the live environment. Okay, so it's the different stages of places where we move our code towards. Again, Scrum Masters, you need to be aware of all these different spots. Other terminologies that you as a Scrum Master should be familiar with or should have a some understanding of is what it means to be cloud. What is CI/CD? You should know that by now if you are working as a Scrum Master. If you have not, you need to go look into it. DevOps, SRE, what is a GUI? That's a fundamental basic stuff, right? What's virtual mean? What's physical? What is a token? What is a cookie? What's a session? You should have some idea of what these are. So going back to why this video was created, why is it that you should know all these things? Because you're in there to help the team deliver value, right? So you should understand the process, the steps that it takes for the team to create that. And knowing that helps. You don't need to be expert in any of those things, but you need to know the steps, the process of what a team goes through. Hopefully, this addresses some of the questions around should a Scrum Master should be technical or not. My answer is still going to be no, you do not need to be technical, but you should know some of these things. All right, that's it for today. Bye.